Welcome back. So, in this video we're going to be talking about my progress on the Electron-based retro game engine I'm writing to try to basically... It's a different way of rewriting the Minecraft game. I'm doing it two different ways right now. In this one, I'm doing a lot more of building it up from scratch and walking you through, like, this is the actual app running right now, the state that it's in. This screen right here is basically what we saw last time. It has the buttons in place to control this counter down here. The counter is still stored in local storage. You can drag the player around, you can move them with the arrows. If you hit escape, it pops out of that scene, back to the main menu scene where the game starts. Pop into the, click the pixels button. It's a demo of some of the pixel functionality and the 9 slicer component that I built recently to... It's another way I was considering rendering buttons. I don't know if I'll stick with it or not, although I like the way it looks. I'm not sure I like how big it is on the screen. So I don't know. I'm going back and forth. And I recently added the ellipse function, which I wrote about on Medium Argo. I posted another video about it, if you're curious. And then, also, you can exit out. But behind the scenes, almost everything has changed. The basic infrastructure of the app is what it was before. It's an Electron app, so we still have the server folder controls the main process. The client folder has the code for the renderer process, and the preload folder contains the code that kind of glues the two together. But I have implemented a whole lot of other details on top of it. Basically, I moved the whole project to TypeScript. Minecraft-TS, it's right there in the name. It was time to get it in TypeScript. I'm also trying to use this project to try to practice some of the standards that we're using in my day job. So, you know, implemented TypeScript for the language should help me control the project a little bit better as it grows in complexity. Implemented ESLint and Prettier configurations. What those do is, if I were to come in here and decide, you know, I'm just going to remove those semicolons. JavaScript doesn't need them, and I want that to be on that line because I'm being sloppy. And it just makes your code look weird. It's technically still runnable, but it looks weird. As soon as you hit save, Control S, the linter and Prettier libraries pop it back into shape. And you also see that if you try to check anything in, it will pre-lint it and see if you are matching code standards. Because it's running in TypeScript, Electron is still based in JavaScript. I have the NodeMon library going. Basically, NodeMon, it's a monitor. It watches the TS and JSON and env files, and if anything changes in the root directory specified by that dot, it will then rebuild and then restart the project. And what else? Implemented C-spell on here. What that does, let me find a good example. Don't need all those. See, it's saying that the 9 slices declared but never read, so we're going to cut it out. We don't need it. But let's say we made another sprite and call it Player. It's like a player, but with a U. You see the blue squiggles there. Player is undefined. It doesn't know that word, and I can either add it to the dictionary or I can tell it to use the correct spelling. Player. Of course, I already have a player, so I don't want to do that. And same thing inside. It does spell checking on strings. If I got confused, started writing in Spanish instead, it's going to fuss at me. So that's useful because I hate finding misspellings in my code. And what else? Implemented, what Husky does is it mandates certain types of, well, commit messages and pre-commit. As it hooks into Git, and this is what controls linting everything as it goes in, and then making sure you spelled it right and are following certain standards with your Git commit messages. If you look in package.json, I'm still learning all this. I learned a whole lot of it today. But when you do a lint stage, it's going to run prettier, it's going to run ESLint, and it's going to check all your spelling. It's going on this commit lint package, make sure you're using conventional commit messages. Various things in here to control what version of Node you're using. And I'm still learning how this bit works, but basically if you merge a branch or change set to main that has either chore or patch in the title of, or in the commit message or that type of thing, then it will update the version number, which I'm sure that'll be useful later. I'm still not completely happy with how I implemented NodeMon. Like when I quit the application, it doesn't always quit the NodeMon process, so it gets weird when the processes start stacking up here. See, I just saved that and it relaunched the process. You can see there's 2 of them running. So when that happens, I have to kill the terminal and restart it. So I'm still working out that bit. As to the actual how the app works, it starts at the server. The app loads in environment variables. You can see there's a .env file, nothing really secret in there. It sets the environment to whether you're in debug mode. If you set this to true, it'll open DevTools by default when you run. I'll probably eventually use the debug flag to also control whether the native menu appears at the top of the window. Running in the dev environment, and using convict to help me manage the configuration. As default values, it controls what those values can be. It labels them, so by 3 months from now, when I come back to this project, I will still know what they do. So it does all that, loads into configuration, uses .env to load the configuration, then it loads the main app, sets up the event handlers. Let's see, when it's ready, it builds the API. That hasn't changed from last time. Pretty sure I had that running last time I demoed this project. Added the system exit handle, or IPC main handler, so that you can call that from the front end and it will tell the application to quit. Let's see. The paths thing, where it gets the path of the client and preload. The thing is, TypeScript, when it compiles it, it dumps it into the dist folder, and then Electron has to be able to then read those files to populate the browser. So I wasn't able to calculate the paths like I was before. Right, I was getting the app path from the application, but it's had some consequences. I'm not sure I'm going to handle actually building the executable. It's not working quite yet. It works like this. I'll work out the build in a bit. I know that I read that this has some problems when you're building the executable. So it still needs a bit of work on that bit. Let's see. The patches folder was interesting. That one was actually, let me show you. When I converted from JavaScript to TypeScript, I found that some of the packages were broken. In this case, image.js, the type definitions didn't work. Install a patch package, and then you can go into the node modules folder and fix whatever was broken, and then do npx patch package to patch the image.js project in the node modules folder, it creates the patches folder, and then I was able to easily use the CLI to push up a GitHub issue. So that was neat. I had one of those issues accepted for another project. I think it was the ML regression package. I was able to push up a fix for that got accepted. And a lot of this is basically the same. Getting into the client folder, the flow of the app begins with index. You create the game, and then you tell the system to initialize it with that game. The initialize function just sets up all the event handlers and the frame ticker. Tells it to keep requesting the animation frame and then go to the game for updates and renders. Has separate update and render intervals. Ultimately, I think I'd really like to pull the update code over to the server side. I think that'd be pretty neat, but I'm pretty far away from that. Inside the game extends game. The root game is basically, it knows about the screen, the tile set, the font, the mouse cursor, and a collection of scenes. And ultimately, I'm going to want the mouse cursor to be stored in some sort of sprites array. But because of the way it's implemented, it has to be drawn last, and it was easier to just keep it separate. Each scene, the scene is where the actual content of the project happens, and it can update and render, and it can respond to keyboard and mouse events. You enter and exit a scene, and it has some properties that proxy the game object. So you can pull on the font or tile set or the size of the screen. In this case, creating a Minecraft game, and all it does really make sure the screen is clear and load up the main menu scene. Main menu scene is creating 3 buttons for sprites, pixels, and exit, and it has 3 on-click handlers the on-click handlers tell it to enter the different scenes: sprites test scene, pixels test scene, or to quit. And then you can see in the sprite test scene loads up some UI elements and the player sprite, which is the demo that we've been looking at for a while. The pixels test scene renders some different shapes, like animates some shapes, draws a line, draws an ellipse, lets it bounce around. And that's just for testing out the raster graphics functions that I've been developing through the Medium articles I've been writing. And that is basically it as far as code review goes. I'm continuing to build up these folders. I changed the way colors are being retrieved. I had a get 1 and a get 4, whether you want to translate one color or 4 colors at a time, but it really makes the most sense just to pass in any number of colors in and get any number of colors out, which is what it's doing now. And I'll get more into some of the nitty-gritty details in later videos, but that is basically what's going on, and looking forward to continuing to develop this over the next however long. So thanks for watching, and let me know what you think. Always happy to receive input, and hope to see you next time. Later.